We can create parametric component families to allow us to change the properties, their dimensions and materials by adjusting parameters. Parametric families are very easy to work with because they can easily be adapted as needed to meeting our modeling needs. Let's start by making a new family, and we'll add parameters to this family definition that let us dynamically change it. Open the Revit menu and choose New Family. We'll start by choosing a template for this family from the Template section of the library. Every Revit family is based on a template that specifies the category for the family or any special hosting requirements. Most families can be placed anywhere in a project or model, but some families can be defined as being a wall or ceiling hosted. Components from these families can only be placed in the appropriate hosting elements. Let's choose the furniture template to create a new console table with no special hosting requirements. We'll be able to place this type anywhere in the model. Before we get started modeling, let's save this new type to our library and name it console table. Open the plane view for the reference level. You will see that there are two reference planes already defined in this template. These are center front back and center left right. The intersection of these planes is the placement point of the component that will be placed where you click the mouse as you place the object in your model. We will add new reference planes to define the boundaries of our new console table. First, create reference planes that runs from left to right of both sides of the center front back plane. These will be used to define the front and the back sides of our table. Then create reference planes that runs from the top to the bottom of both sides of the center left right plane. These will be used to create the left and the right side of the table. Now let's switch to an elevation view and we'll add a reference plane to define the top of our table. We will give this a name so it will be easy to identify later when we are setting the work plane. Place it and let's name it Tabletop. Let's add some dimensions that will give us the ability to dynamically reposition these reference planes. First, let's create a dimension between the left, center, and the right reference plane. We'll set the equal constraint to make sure that the left and the right sides are always positioned equally around the center line. Now we will add an overall dimension to our sides. We'll use this to control the length of our table. Rather than giving this a fixed dimension, let's add a parameter to this definition line. That will let us dynamically change it as a property of the table. Select the dimension and open the label pull down in the options bar and choose Parameter. We'll leave it a family parameter. Now give it a name. Let's name it Table Length. Now set this a type parameter. That means that this dimension will be the same for all components of the same type. To change this dimension, the user would define a new type and set the desired type as a type property. This will be a parameter of the type length and we'll leave it grouped in the dimension section of the properties dialog. Next, we will add similar dimensions between the front and the back reference planes. First, add dimension and set the equal sign to make sure the front and the back reference planes are always equally spaced between the center. Then we'll add a dimension that will define the width of the console table. Select the dimension and add a parameter to it. We'll call this one Table Width. It will also be a type parameter. Let's switch to an elevation view. We can set a similar dimension to control the height of the table. This one won't need the equality constraint since we want the table to be placed above the reference level. Add a dimension between the reference plane and the top of the reference plane. Then add a parameter to this dimension. We will call this one Table Height. Now that we've created parameters to move the reference planes, let's test them to make sure that they have the desired effect. Open the Family Types tool. The parameters we've added in the last step appear in the dimension section of the dialog with values measured from the current model. Enter a new value for the table width, then click the Apply button to verify whether the reference planes move properly. Let's try another value. Now let's change the table length, and again click the Apply button to verify that the reference planes moves as expected. We can repeat these steps to systematically test each of our parameters. Now let's switch to an elevation view and check the table height parameter. This parameter is also working properly. Back in the Family Types dialog, we can define a few types with different dimensions that we can use to test our new table component. Click the New button in the Family Types section of the dialog and enter a descriptive name for this new type. We can change these values or define another new type and change them there. When we're done, we will have several types to choose from. You can see them here in the name drop-down. These would be the name that appear in the type selector. We are now ready to add forms to our components. We can add solid forms or void forms. We can use any of the form generation methods. To make these forms dynamic and resizable, we will use the reference planes to define the key aspects of the geometry. That way, when a reference plane is moved, the form will be resized. Now let's see how that works. Switch to the reference plane view and we'll create an extrusion to model the tabletop. Sketch the boundaries for this extrusion, then use the Align tool to move the edges to the boundaries and lock them to the reference plane. Do this for all 4 sides of the extrusion. Finish the extrusion. Then let's switch to the elevation view to set the top and the bottom for the extrusion. You can see the extrusion we just placed at the reference level. By default, it starts at 0 and ends at 250 millimeters. Let's use the Align tool again, this time to lock the top of the extrusion into our reference plane for the top of our table. The tabletop shouldn't extend all the way down to the reference level, so let's add another reference plane to control the bottom of the tabletop. Then use the Align tool to lock the bottom of the extrusion to it. Next, we will add a dimension to set the thickness of the tabletop. This dimension will extend from the tabletop reference plane to the reference plane at the bottom, and always be careful to dimension the reference planes and not the surfaces of the form. Let's set the dimension to 40 millimeters, and we will leave this a fixed value so the tabletop will always be 40 millimeters thick regardless of the table height. Now let's switch to a 3D view and confirm that the form resizes properly as the parameters change. Open the Family Types and use the different types or change the parameters and click Apply. As we make changes, our tabletop changes its size based on those dimensions. We will add a pedestal base beneath the tabletop. Switching back to the plane view, you can see that we've added reference planes and the parameters to define the pedestal length and pedestal width. Then, in the elevation view, you will see that we've added another extrusion that stretches from the reference level to the reference on the bottom of the tabletop. Open the Family Types again. Now we'll confirm that the two forms are responding properly to changes in the parameters. We can also assign materials to each of these forms, either as a fixed material or as a parametric material that can be changed by setting the component type or instance property. Select the tabletop form. In the Properties palette, you can see this form is set to use the material defined by the category. So by default, this form will use the material assigned to the furniture category. Click the material value, then click the small button to open the material browser. You can choose one of the existing materials from the list or create a new material. Let's duplicate the existing material and create a new material called console table wood. Now let's give this a brown shading. Now let's select the pedestal form and assign the same material to it. As a final step, let's add parameters to material setting for each form so we can easily change the materials in the project. Select the tabletop form and click the small button to the right of the materials value in the Properties palette. This button opens the Associate Family Parameter dialog where we can add a parameter that will let users change this value. Click the Add Parameter button and then create a new parameter called Table Frame. Let's make this an instance parameter so the value can be set independently for each instance of this component. Let's set up a similar parameter for the pedestal. Select the pedestal form, click the Add Parameter button, and then create a new parameter called Pedestal. Let's make this an instance parameter so the value can be set independently for each instance of this component. Save the family so we can load it into the project. To place our table, open the Place component or load it directly from the family. Now let's place an instance of our family into the model. In the type selector we can choose the different types. Once placed, we can also select the instance and change its type within the model. Next, we can make a new type in order to make a new type with different dimensions. Duplicate the existing type and give it a new name. Change the dimensions and select OK.